Previously we were discussing about the applications of equilibrium constant, and we have discussed the direction of reaction which is known by the equilibrium constant. How equilibrium constant help us to get the idea about the direction of reaction. Now the second point, the second application we are going to discuss, that is extent of reaction. By the equilibrium constant, by the value of the equilibrium constant, we can get the idea about the extent of the reaction, that how much reaction is proceeded and how much is left, and in which direction is the reactants are dominant, is the products are dominant, what is the extent of the reaction. K, as we know, according to the equilibrium constant expression, K is equals to the concentration of the products and the concentration of the reactant. So which is representing that K is directly proportional to the products and inversely proportional to the reactant. If the concentration of the products are increased, the value of K will be increased. If the concentration of reactants are increased, the value of the K will decrease. So their reactants and equilibrium constant are inversely proportional, and products and the equilibrium constant are directly proportional. So by the value of the K, by the value of the equilibrium constant, we can get the idea about of the extent of the reaction. If the K is high, the concentration of the product is high because they are directly proportional. So how we can get the idea about the extent of the reaction? Let's talk about it. If the equilibrium constant is greater than 10 raised to the power 3, which is 1000. So if the Kc is greater than 10 raised to the power 3, then products predominates, reaction proceed near to completion. If the Kc is greater than 10 raised to the power 3, which is representing that products are dominated, reaction is near to completion. Products are more formed. Here you can see 2.4 exponent 47 is the equilibrium constant for this, the value of equilibrium constant for this reaction, for the formation of water at 500 Kelvin temperature. So you can see the equilibrium constant for this reaction is higher than 10 raised to the power 3. So products are near to completion. In a second reaction, in the formation of hydrochloric acid, the value of the equilibrium constant is 4.0 exponent 31, which is higher than 10 raised to the power 3. So that's why this reaction is near to completion. By the value of the K, we can get the idea that products are predominant and this reaction is near to completion. In the same way, in the third reaction, the equilibrium constant having a value 5.4 exponent 18, which is higher than exponent 3. So that's why this reaction is near to completion, products are dominant. So this value of equilibrium constant give us idea that how much reaction is completed and how much reaction is left. Next, if the equilibrium constant having a less value than 10 raised to the power minus 3, which is representing that the reactants are predominant. Reaction proceeds rarely. The concentration of the reactants are more, product is very less formed. In this reaction, you can see hydrogen gas and oxygen gas are the products. So due to this value of Kc, this is very less than 10 raised to the power minus 3. 10 raised to the power minus 3 is higher than 10 raised to the power minus 48. So Kc is very, very less than this value in this reaction. So which means reactant are in higher amount, reaction is very, very far away to completion. This reaction need much more time to be completed. In the same way, second reaction, Kc having a very less value, very less value than 10 raised to the power minus 3, which is representing that this reaction is very less to be proceeded, or reactants are predominant, reaction needs much more time to complete. If the value of the Kc is small or very small, so what change we will observe? If the value of the Kc is small, like 10 raised to the power 1, this is a small, not very small. So in this case, the reaction doesn't proceed appreciably in the forward direction. But if the value of the Kc is very small, like 10 raised to the power minus 13, this is very small. So in this case, we are assuming that a very little forward reaction is take place. The forward reaction is very less. This is the side of the forward reaction. So forward reaction is very less because Kc is very small. In case the Kc is between the 10 raised to the power minus 3 and plus 3, then what will happen? This will be the condition in which we are saying equilibrium is approximately established. The concentration of the reactants and the products are equal, appreciably equal. So here you can see the value of Kc is 57, and in this case the value is 4.64 exponent minus 3 between 10 raised to the power minus 3 or and 10 raised to the power plus 3. Between these two values, the Kc having for these two reactions. So which is showing the concentration of the reactant and products are equal. They are at the equilibrium. So by the value of Kc, we can get the idea about the extent of the reaction, that how much reaction is proceeded, how much products are formed, and how much reactants are present in a chemical reaction. Next, the effect of condition on the position of equilibrium. What is the effect of conditions on the position of the equilibrium? On which condition equilibrium is effect? Kc remains constant at constant temperature. If you are changing the temperature, then Kc will change. If the Kc is constant, then there is no effect on the equilibrium constant. But the position of the equilibrium varies if you change the temperature, pressure and concentration. So Kc, the equilibrium constant, and the position of the equilibrium, these both things are different from each other. Kc is a different thing and positions of the equilibrium are different thing. Positions mean that how much products are formed, how much reactant are formed, when the equilibrium will occur. So these positions, these things are different and these conditions will vary if temperature is changed, pressure is changed and the concentration of the reactants are changed. So if you are changing the condition, position of equilibrium change, but equilibrium constant doesn't change. So these three were the application of the equilibrium constant. Next, we having a very important and very interesting topic, that is the Chatelier's principle. In equilibrium constant, we do not move forward without discussing the Chatelier's principle. Basically, what is Chatelier principle? Chatelier principle is basically the discussion of the increase of the production. How we can increase the production? How we can increase the product which we want? How we can increase that? Basically, in a Chatelier principle, we discuss by which conditions we can get our required product in a more amount. We prepare a lot of chemical compounds in a big laboratories, in a big industries, because we want those compounds in a large amount. If the equilibrium is maintained, then how we can get the larger amount of our required product? So this Chatelier principle help us to get the highest yield in industries. So let's start how we can get our product in a higher amount by changing which factors we can get the higher amount of product. So let's talk about it. As we know, equilibrium of the reaction is basically when the rate of the forward and the rate of the backward reaction are equal. That is the condition of the equilibrium. That is the chemical equilibrium. That this is saying that the reaction is at equilibrium when the rate of forward reaction and the rate of the backward reaction are equal. And equilibrium is basically the reversible reaction. If there is irreversible reaction, then there is no equilibrium condition. And equilibrium condition is considered as the most stable condition. If we change concentration, pressure, temperature, volume, or adding any kind of catalyst to this reversible reaction, equilibrium is a reversible reaction. If I am adding more concentration of the reactant or the product, if I am changing the pressure, if I am changing the temperature, I am changing the volume of the reaction mixture, I am adding some catalyst, then this reversible reaction, the state of equilibrium will be disturbed. And according to Chatelier principle, this reaction want to attain its equilibrium position again by undo the change. Equilibrium will try to undo the change. Equilibrium is disturbed by changing pressure, concentration, temperature, adding catalyst. The equilibrium reaction wants to attain the equilibrium condition. So that's why equilibrium state will try to undo that change. How equilibrium state undo those changes? This is all about the Le Chatelier principles. One by one, we are going to discuss about this. Before that, you have to know the statement of the main statement of Le Chatelier principle. If a stress is applied to a system, stress is change in concentration, change in pressure, change in temperature, or if you are adding any kind of catalyst to a system at equilibrium, then system acts in such a way so as to nullify the effect of stress as far as possible. So the equilibrium system will try to cancel out, nullify that effect which is disturbing the equilibrium condition, because equilibrium condition is the most stable condition, and due to that equilibrium we can get the higher amount of product. Let's talk about one by one the conditions. First condition or the effect on the conditions of the equilibrium is concentration. If we are changing the concentration, then how it will affect the equilibrium? Here you can see this is the equilibrium reaction. Formation of ammonia. This is the industrial process formation of ammonia, that is Haber process. In industry, this is known as a Haber process. Formation of ammonia. We are forming ammonia. If we increase the concentration of nitrogen, what will happen? Nitrogen gas is a reactant. These all are in the form of in the state of gas. Nitrogen gas, hydrogen gas, and ammonia gas. If the concentration of nitrogen is increased, then what will happen? If we are increasing the concentration of the nitrogen, then equilibrium will disturb. To maintain that equilibrium, reaction move forward to consume all the ammonia that we have added. Reaction increase the forward reaction. Reaction start to forming more ammonia because equilibrium is disturbed. So by adding ammonia, equilibrium is disturbed. More concentration of ammonia is present in a mixture. So to consume, to reduce, to remove that excess ammonia from the reaction mixture, this reaction start moving forward and making more and more ammonia. This nitrogen will move towards the forward direction. This reaction move towards the forward direction. In the same way, if you are increasing the concentration of the hydrogen gas in a reaction mixture, then that equilibrium reaction will be disturbed. This reaction, this equilibrium will try to undo that change. How equilibrium state undo that change? That change is undo when all the excess added nitrogen is consumed. How the excess added nitrogen gas is consumed? When the reaction will move forward. So if you are increasing the concentration of the nitrogen gas or the concentration of the hydrogen gas, the reaction will move forward. So what is the effect of change of the concentration of the reactant? The reaction will move forward towards the product. In this way, you can get the excess amount of ammonia in industries. In this way, you can get the higher yield of ammonia. There is another way by that you can get the higher amount of ammonia is that if you are removing this ammonia, remove this ammonia from the reaction mixture. Ammonia is forming and you are continuously removing that ammonia. So when you are removing, equilibrium will disturb. Reactants are quickly reacting with each other and making continuously more and more ammonia because the concentrations of the reactants are increased but there is no product, so they will shift towards the product fastly because there is no ammonia on the product side because we have removed the ammonia. So in this way more and more ammonia will form by Haber process in industries. So if you are increasing the concentrations of the reactants, the reaction will move forward and more product is formed. If you have removed the product, then more and more reactants will react to make product, to attain equilibrium, to maintain equilibrium, because this is the reaction which takes place at equilibrium. This is a reversible reaction basically. Another reaction, formation of sulfur trioxide. This is a contact process which takes place in industries with the name of contact process. So if you want to increase the production of sulfur trioxide, how you can do this? By increasing the concentration of the sulfur dioxide and the oxygen gas, you can increase the concentration of the sulfur trioxide, or by removing the sulfur trioxide you can increase the concentration of this product sulfur trioxide in the same way as we have discussed in the formation of ammonia. If you want to increase the concentration of product, so you have to increase the concentrations of the reactants. If you want to increase the concentrations of the reactants, so then you have to increase the concentrations of your products. Next is the effect of temperature, the effect of pressure or volume on the state of equilibrium. Let's talk about this. Effect of pressure or volume on equilibrium state. If you are increasing the pressure, equilibrium shift to that direction which has lesser number of moles. In a reaction mixture, if you are increasing the pressure, the reactants or the product, any side having a change due to that change in pressure, equilibrium will shift towards that side which having less amount of moles. In this reaction, you can see this one having 1 mole and this one having product having 2 mole. So if you are increasing the pressure, what will happen? On the reactant side, the number of moles are less. So the product will be moved towards the reactant. Backward reaction will be increased. Equilibrium shift towards the backward side. So equilibrium is shifting towards the backward side when you are increasing the pressure, so the reactants will be formed more and more. In the second reaction, here you can see 1 plus 3, 4 number of moles of the reactants and 2 number of moles of the product. So product having less mole. If you increase the pressure, reaction will move forward. Equilibrium will shift towards the forward direction. Why equilibrium shift towards the forward direction? Because you are increasing pressure and the number of moles are less on the product side. So that's why reaction will be forward. Reactants are combining more and more to make more amount of product to attain that equilibrium, to maintain that disturbance that is caused by the increase of the pressure. As we know, there is an inverse relation between pressure and volume. If you increase the pressure, volume is decreased. So this is reverse for the volume. Clear? So if the volume decreases, equilibrium shift to the direction which having less number of moles. So if you have understand about the change of the pressure or the effect of the pressure on the equilibrium constant, then you can easily get an idea about the change of the volume, because volume is the inverse to the pressure. If you are increasing pressure, volume will decrease, you know this. If you are decreasing pressure, volume will increase. So pressure increase, the equilibrium shift to the direction which has lesser number of moles. If you are decreasing pressure, then equilibrium shift towards the side where there is less number of moles. How we can explain this? Less number of volume. Less volume means there are more number of moles. Less volume means more number of moles per unit volume. More number of moles. If the volume is more, then number of moles are considered as a less, because there are much volume but there are very less number of moles. If you are applying pressure, increasing pressure, volume will decrease. Decreased volume is showing that the number of moles per unit volume are increased. As we know, the number of moles are same, but if we are talking about per unit volume, then we are saying the number of moles are increased. So the concentration is number of moles per unit volume. As we know this, concentration is mole per unit volume, that is molarity that we takes when we calculate the equilibrium constant. So by decreasing the volume, basically concentration is increased. By decreasing the volume, concentration is increased. Concentration is increased. By decreasing the volume, concentration is increased. So if you want to decrease that concentration, what you have to do? You have to shift the equilibrium towards the lesser number of moles. Because by decreasing volume, it looks like the concentration is increased. But in reality, this is not happen. The concentration is not increased. By decreasing volume, concentration or the number of moles per unit volume is considered as increased. So that's why to decrease that concentration, equilibrium will shift towards the lesser number of moles. That's why equilibrium is shift, to maintain their equilibrium state. Next, see these examples. Here you can see some examples to better understand the concept of effect of pressure and volume on equilibrium. In this reaction, here is the one number of moles and here are 2 moles. Products are 2 mole and the reactants are 1 mole. If you want the product, what you have to do? You have to decrease the pressure. If you are increasing pressure for this reaction, the product will move towards the reactant, because reactant having less number of moles and products having higher number of moles. So by the increase of the pressure, equilibrium shift towards the less number of moles, so it will move towards the reactants. But you want more product, you don't want the reactant, you want the products. So how you can get the product? By the decrease of the pressure, equilibrium will shift towards the product. Equilibrium will shift towards the forward direction. you will better understand this by general gas equation, that is PV is equals to nRT. According to this equation, we know that pressure is directly proportional to the number of moles. So if we are talking about the total pressure, then we are relating with the total number of moles. If the total pressure increase, the number of moles are increased because number of moles are compact per unit volume. So it look like that number of moles are increased by increasing the pressure. So that's why you need to move your equilibrium towards the lesser number of moles to attain the equilibrium. In this reaction, reactants are 2 mole and products are 2 mole. So when in an equilibrium equation, when in an equilibrium reaction, the number of reactants and the number of products are equal, delta N is 0, then there is no effect of pressure on the reaction. Remember this, if the number of moles of the reactant and products are same, then there is no effect of pressure. Because both side number of moles are same, so there is a no shift of the equilibrium on any side. Let's talk about the effect of volume or pressure quantitatively on equilibrium position. In these reactions we were discussing qualitatively, now we are going to discuss quantitatively, that how volume and pressure affect the equilibrium constant. Here is the reaction. This reaction is with the less number of moles of product. Here you can see product having 2 moles and the reactants having 3 moles. If the products are less and the reactants are more, we have written the equilibrium constant expression for this reaction, and you know how to write this expression because we have discussed in our previous lesson that how to write a expression for equilibrium constant. So this equilibrium constant expression is showing that V is the volume of the reaction mixture at equilibrium state. A and B are the number of moles of the SO2 and O2 taken initially, and X and 2X are the number of moles of the oxygen and SO2 which has been reacted at equilibrium according to this expression. Clear? So when volume is increased for this reaction, when volume is increased, what will happen? X has to be decreased. When the volume increase, X is that amount which is used to make a product at equilibrium. So if the volume is increased, X should be decreased. In this condition, what will happen? It means reaction will move in backward direction. Reaction will move backward direction. Reaction will move backward direction because if the volume is increased, which is showing that pressure is decreased. If the pressure is decreased, then this will move towards the backward side. This is same like when we have previously discussed, then the equilibrium shift towards the lesser number of moles if the pressure is increased or the volume is decreased. So these are the lesser number of the moles. Here you can see 2 is the less number of moles as compared to the 3. So if you are increasing the pressure, the volume will decrease and reaction will move towards the forward side. But if the volume is increased, what will happen? The reverse will happen. The reaction will move towards the backward side. If the volume is decreased, then reaction will move towards the forward side because pressure is increased and volume is decreased, and the equilibrium will shift towards the lesser number of moles. So here you can see product having less number of moles. So by the increase of pressure or decrease of volume, equilibrium constant will shift towards the product. If we start the reaction or we proceed the reaction towards the increased number of the moles, here you can see the product having higher number of moles, 2 moles, and the reactant having 1 mole. This is the equilibrium constant expression. In this reaction, if you are decreasing the volume, the reaction will be backward, and increasing the volume, reaction will be forward. By the increase of the volume, which means pressure is decreased, so the reaction will be forward. If you are decreasing the volume, increasing the pressure, then the reaction will be backward. Why? Because on the product side the number of moles are higher, so by the increase of the pressure it will move towards the lesser number of the mole. If you are decreasing the pressure or increasing the volume, so it will move towards the product side, forward direction. Next, effect of temperature on equilibrium constant. How temperature affects the equilibrium constant? If you are increasing the temperature, equilibrium will shift to that direction which proceed with absorption of heat. Increase of the temperature in an endothermic reaction favor the reaction to that direction which shows the endothermic nature. For example, A and B are reacting to each other and making C and D product. And A and B need energy, need temperature to react to make C and D. So this reaction is endothermic. So for endothermic reactions, you have to add the energy. So this reaction will move forward. If you decrease the temperature for this reaction, you are going to decrease the temperature. This is endothermic reaction, but you have decreased the temperature. So it will not move towards the forward, it will move towards the backward direction. Clear? So in endothermic reactions, if you are increasing the temperature, it will move towards the forward side. If the reactants need energy, need temperature to move towards forward. If the reaction is exothermic, so by the increase of the temperature, it will not move forward, because that type of reaction wants to release the energy. So decrease in temperature favor exothermic reaction, and if you are increasing the temperature, endothermic reaction will be favored, which depends upon if the reaction is endothermic or exothermic. So you have to consider that this reaction is endothermic. So if you are increasing temperature, it will move forward because it needs the temperature to make a product. In the second step, when Hi plus hydrogen or iodine reacts with each other, they will make hydrogen iodide. In this reaction, if you are going to add the heat, it will not move towards the product because this is not favored as an endothermic reaction. If you are increasing heat or temperature in this direction, in this reaction, it will move backward because backward direction is endothermic. This backward direction is endothermic. This backward direction need an energy to make products. So in endothermic reaction are those in which you have to provide the energy, provide the temperature to proceed the reaction. And in exothermic reaction, you don't need to provide the energy or the temperature because on those reactions, energy is released from the reaction. Let's take the example of another reactions. Here, formation of ammonia. If you are taking nitrogen gas, hydrogen gas to make ammonia, you need 22.4 energy. This amount of heat or energy or enthalpy you need to make it proceed forward. This is the endothermic reaction. So this amount of energy is required to make ammonia. In this reaction, the formation of carbon dioxide from carbon monoxide and water, enthalpy change is minus 41.84 kilojoule per mole. So this is showing that this is an exothermic reaction. So if you increase the temperature in this exothermic reaction, this reaction will not move forward because this is already the exothermic reaction. This reaction needs to release the energy. So if you increase temperature of this reaction, it will move backward, because if you want to combine carbon dioxide and hydrogen, again you have to add the energy, add the temperature in it to make them react and make carbon monoxide and water. So by the increase of the temperature, this reaction will be backward. This equilibrium of this reaction will be shift towards the backward direction. So keep in mind when you are writing about temperature, by the increase of temperature, endothermic reaction move forward and exothermic reaction moves backward. By the decrease of the temperature, when you are decreasing the temperature, for endothermic reaction, the reaction will move backward and it will move forward if the reaction is exothermic. Effect of temperature on solubility. How temperature affects on solubility? For example, potassium iodide is soluble when this amount of energy is absorbed. This amount of energy is given to the system. So if the temperature is increased for this reaction, it will move forward because this reaction need 21.4 kilojoule per mole of energy to be proceed. Potassium iodide need 21.4 kilojoules per mole of energy to be soluble. So by the increase of the temperature, this reaction will be forward. If the reaction is exothermic and you have increased the temperature, solubility will decrease. That substance will not be soluble, like lithium chloride and lithium carbonate. These two compounds their solubility will decrease. Their solubility will decrease if you increase the temperature. If you decrease the temperature for the solubility of these two compounds, then they will be soluble. So if the solubility of some compounds happens by the addition of the heat, then the reaction is forward. If the solubility is affected by the increase of the temperature, then those compounds will not be soluble. Equilibrium shift of these reaction will be affected. Next and the last thing, that is effect of catalyst. How catalyst affect the equilibrium constant? Basically, catalyst or the inert material, any of the inert material, not only the inert gases, helium, neon, argon, krypton, any of the inert material or catalyst which is used in a chemical equilibrium, reactions of chemical equilibrium. Catalysts do not react with the reactants and products. We know this. Catalysts only increase the reaction rate on the product side or on the reactant side. They just increase the rate. They do not react with the reactant and products. They do not do any change in their concentration. So we are going to discuss the effect of catalyst. Effect of catalyst is just that it increase or decrease the reaction by lowering the activation energy. If the reaction is proceed at constant volume, then there is no effect of catalyst. Then there is no effect of, if the volume of the reaction is constant, then there is no effect of catalyst. But if the pressure is constant, then equilibrium will shift on that side which having more number of moles. Remember, this is different from the effect of pressure. If the pressure is constant, there is no change on pressure, then by the addition of catalyst, equilibrium will shift to that side which having more number of moles. So here you can see products having 2 moles and the reactants having 1 mole. If the constant volume, then there is no effect. If the constant pressure, then what will happen? The reaction will be forward. It will move towards the products because product having more concentration. more number of moles. So by the addition of a catalyst, the reaction will be fast and more towards the product side. Equilibrium will shift towards the product side. In this reaction, you can see reactants having 4 moles and the products having 2 moles. If the volume is constant, then there is no effect. But if the pressure is constant, then what will happen? Here you can see reactants having more product. So by the addition of a catalyst, products will move towards the reactant. The equilibrium will shift towards the backward side, because by the addition of a catalyst, reaction will shift to the equilibrium will shift to that side which having more number of moles. Here you can see the example. As I told you when I have started this lesson, that Le Chatelier principle is basically to get more yield of the product. So in this reaction, now we have discussed all those conditions, all the effects, the effect of concentration, effect of pressure, effect of temperature, effect of catalyst, that how we can get more yield of hydrogen iodide for this reaction. So first thing is concentration of, if we are increasing the concentration of hydrogen or iodide, we can get more product. If we remove this product at equilibrium, then reactant will more and more react together to make the product to stable the equilibrium, to attain the equilibrium, to maintain the equilibrium, to nullify the disturbance of the equilibrium. So in this way we can get more and more potassium iodide. What is the effect of pressure? There is no effect of pressure, because change in number of moles is 0. The number of moles of product minus number of moles of reactants are 0. So that's why there is no effect of pressure on any side. If we are increasing the temperature, what will happen? If you are increasing the temperature, it will move backward, because this backward reaction is endothermic. So if you are increasing the temperature, it will move towards the reactants. The last thing, addition of catalyst. Catalyst have no effect because both sides having same number of moles. If the one side having more moles and the other side having less mole, then we can say that there is effect of catalyst. If there is the same number of moles, then there is no effect of catalyst. Here are the some examples. For these examples, you have to tell me what is the effect of concentration, pressure, temperature, volume and catalyst have. So you have to solve these 3 examples, write all the effects and share with me.